Every year, companies pour massive budgets into acquiring new customers, completely unaware of the active users silently preparing to cancel their accounts. To stop this leak, we are going to build a machine learning model from scratch that predicts customer attrition before the cancellation button is ever clicked. If you want to follow along, you will need basic Python skills, a coding environment like Jupyter, and the Kaggle Telco customer churn dataset. Writing the code is only step one. Our actual objective is to generate a mathematically sound, prioritized save list for the retention team to call. A predictive algorithm is useless in a vacuum. We have to bridge the gap between abstract data science metrics and executive-level return on investment. Step one is getting the data into pandas. We load the telco dataset and inspect the columns, looking specifically at customer tenure, their contract type, and their monthly charges. Before we feed anything to an algorithm, we need to look at the data to see what story it naturally tells about why people leave. This horizontal bar chart compares the volume of cancellations across contract types. You can immediately see the high attrition volume concentrated in flexible month-to-month plans, while long-term users show high loyalty. Now we prep the data for the model. We start by hunting down and filling in any missing values so the algorithm doesn't error out during training. Next, we apply one-hot encoding. Machine learning models require numbers, so text-based categories like internet service have to be translated into numeric binary columns. Pay close attention here. You must ensure your training columns perfectly match your live scoring columns. A mismatch in these columns is the single most common reason models fail in production. Clean, properly encoded, and deeply understood data provides the uncompromising foundation for a reliable predictive model. With the data ready, we split it into a training set to teach the model and a testing set to evaluate it. We start simple with a baseline logistic regression. If a heavier, more complex model like a random forest or a gradient boosting machine cannot easily beat this baseline, we stick with the simpler option. Whichever model we choose, we have to pass it the class weight equals balanced parameter. This forces the algorithm to pay attention to the minority group, the people actually canceling. Because of class imbalance, a model guessing everyone stays is 73% accurate, but ignores the 27% actually churning. To fix this, we use the precision recall area under curve, or PRAUC, ignoring standard accuracy entirely. We use this metric because PRAUC specifically rewards the algorithm for successfully pushing the actual defectors to the very top of our priority list. But ranking is not enough. The probabilities themselves must be calibrated. A model can rank customers perfectly, but output wildly skewed risk percentages. If the model gives a customer a 30% risk score, that must mathematically represent exactly a 3 out of 10 chance that they will actually cancel. An uncalibrated model breaks the business math we apply later. PRAUC, combined with honest probabilities, gives us the precise compass we need for this specific problem. Now we move from predicting who will leave to understanding why the model flagged them. This permutation importance chart ranks the features driving cancellations. It measures how much worse the model gets if we scramble a specific column, revealing the true behavioral drivers behind the churn. Next, we create a financial decision threshold to determine who gets a phone call. We need 3 variables: outreach campaign cost, historical save rate, and a saved customer's revenue value. We divide campaign cost by the product of the save rate and customer value. With our example numbers, the math resolves to exactly 16.7%. Reaching out pays off once a customer's turn risk clears that 16.7% line. We apply this threshold directly to our Pandas data frame to instantly generate a filtered, targeted call list. Calculating probability is data science. Drawing that threshold line based on specific costs and revenue transforms it into a profitable business strategy. When you present this project to an executive, leave the technical terms behind. A vice president does not know what PRAUC is, and they shouldn't have to. Focus entirely on the pitch formula. State clearly that by spending a specific amount on outreach, we can protect a specific amount in monthly revenue. But you still have to prove it works in the real world. To do that, you must establish a holdout control group of about 20% of your flag list that receives absolutely no outreach. Next month, compare the actual turn rate of your targeted list against that control group. The gap between those two numbers is the exact financial lift generated by your campaign. Predictive analytics succeeds when it demonstrably protects the bottom line. If you found this breakdown useful, hit the like button, subscribe for more, and check the description for a link to the source code.